For today's notes, we are going to be looking at factoring by grouping. If you haven't already finished the notes previous to this with factoring out a GCF, you're going to want to make sure you're caught up on that before you move forward with today's notes. Factoring by grouping is something that we are going to use when there are 4 terms. So when we're looking at a polynomial, right, that has 1, 2, 3, 4 terms, that might be something that we can then factor by grouping. So if we are going to factor by grouping, our very first step is going to be to split the polynomial in half. Okay, and if there's 4 terms, right, we're literally just dividing it with 2 terms on one side and 2 terms on the other. So I'm literally just chopping this in half. Now, when I put that line in there, I want to make sure that I'm not cutting off that addition sign because that's telling us whether it's positive or if it's negative, right? So since this is positive, right, we need that addition sign telling us that sign. So on one side, we're going to have a 15a to the third plus 40a squared. And on the other side, we're going to have a 6a plus 16. For our second step, we are going to factor out the GCF of both of those halves. So now we're going to treat this just like it's 2 different problems from yesterday. Okay, so we're going to look at one of these sets. We're going to ask ourselves, what's a number that we can think of that will go into 15, that will also go into 40? So maybe we pick our 5. Do they both have the variable? They do, right? And our smaller exponent is a squared. So we can pull out a GCF of 5a squared on the left. Right, when we divide that out over here, that leaves us with a 3a plus 8. Right, and if we check this again, there's nothing that will go into 3 that will also go into 8. They both don't have an a, so we know we got out the GCF. So we're going to pull that out and just factor out the GCF just like we did yesterday. Then we're going to do the exact same thing over here on the right-hand side. Okay, so we're going to say what goes into 6 that will also go into 16. Well, those are both divisible by 2. Nothing goes into 3 that will also go into 8. So again, we can pull our GCF out here in front. Once we have factored out the GCF of both of them, our next step is going to be to make sure the binomials match. So we want to make sure this right here and this right here are both the exact same. They can't be close to the same. They have to be exactly the same. So this is a 3a plus 8 and this is a 3a plus 8. So those are the same. So that's good. In our next step, we are then going to rewrite this as 2 binomials. And the way that we're going to do this is we're going to take our 2 GCFs and we're going to put them together into one binomial. So this is a 5a squared, and this over here is a positive 2, so plus 2. And then the other one that we're going to pull as our other binomial is the binomial that they have in common. But we're only writing it one time because what we're really doing here is the inverse of multiplication. And if we were to multiply this problem out, right, the first thing we would do is take this 5a squared and distribute it to the 3 and the 8, right? The next thing that we would do is distribute the 2. So the 5a squared is getting multiplied to the 3a plus 8, and the positive 2 is getting multiplied to the 3a plus 8. And so this is then going to be our final answer. Now, we don't always need to write all of those steps in between, so when we go through this process, it's a little bit more straightforward as we go from problem to problem, as long as you can factor out a GCF. So if we look at this next example, the first thing that we're going to do is we're going to split this in half. Now, I personally do not need to rewrite 2 terms to the left and 2 terms to the right, but if you need to do that, that's totally fine. Okay, that can be a personal decision and that can be up to you. So then we're going to factor out the GCF of each side. So over here on the left-hand side, we're thinking about what will go into 14 that will also go into 8. Okay, so that will have a GCF of 2. They both have the variable, and the smaller exponent is a 2. So we're going to pull out that GCF of 2y squared. Then we're going to look on the right-hand side, right? We're going to do the same thing over here on the right-hand side. So what goes into 7, that also goes into 4. You have to find a GCF. So if you say, well, nothing will go into 7, that will also go into 4. Remember, there always is something. If there's nothing else we can think of, then it's a 1. And so we do need to pull this into 1 times 7y plus 4. Because we need that statement to happen where we notice both binomials are the same. Okay, and then once we are there, we can write 2y squared with a positive 1, so plus 1. And a 7y plus 4. Now, both of these problems are obviously dealing both with positives. There's some other examples that we can look at of what happens if there's negatives or more variables involved, and what does that process sort of look like. So if we look at this next example, we have some negatives involved. We're still going to start the same every single time. So we're still going to split this problem in half. And I'm going to look for a GCF over here on the left. Well, 11 and 9 only has a GCF of 1, but they do both have the variable, so I could pull out a w squared. Now, you could write that as a 1w squared. It would be fine either way. The only difference is here, right? We're bringing down this subtraction sign. Can't go any further, so there's my GCF. I'm going to consider the same thing over here on the right. So that has a 1. Now, even though there were subtraction signs in this, when we get to this step, everything is still fine because our two binomials still match. And so therefore we don't have an issue, and we can just say that this is a w squared plus 1 and an 11w minus 9. Now, if we look at our next example, this is something we haven't had to do up until this point with these problems, but it's something we talked about in our last unit. If we look at this polynomial, it's 4 terms, but this polynomial is not in standard form. And if we are factoring, we always want our polynomial to be in standard form. Remember, standard form means that we want it to be from the largest exponent all the way down to the smallest exponent. So we have 3, we have 2, but then we have 0 and we have 1. So for this to be in standard form, we really need these two terms to be flip-flopped. So we really want this to be a 20v to the third plus a 24v squared minus 25v minus 30. Once we get that in standard form, then we can start to go through our steps the same. So we're going to split this in half. We're going to pull out our GCF on the left-hand side. Okay, so we want something that goes into 20 that will also go into 24. And we can pull out a 4. They both have the variable. The smaller exponent is a 2. Okay, so when I divide that out, that will leave me with a 5v plus 6. Can't go any further, so I know I got my GCF. Then I'm going to look over here on my right-hand side. Now, if we say what goes into 25 that also goes into 30, right, we'd recognize that this has a GCF of 5. Now, I'm going to write this in pencil really quickly, so don't write this down yet. I just want you to watch what happens. Right, if I pull out this 5, I'm left with a negative 5v minus 6. And while even though that is my GCF out here in front, I don't end up with matching binomials, right? This binomial doesn't look exactly the same as this one because my signs are off. This 5 is positive and this 5 is negative, and this 6 is positive and this 6 is negative. When those signs are flip-flopped, those are opposite factors. They're off by a negative. And the way that we fix that is instead of pulling out a GCF of 5, we are going to pull out a GCF of negative 5. And while you always can recognize if there's an opposite factor, you should have pulled out a negative. But the key piece to this is that if, right here, our leading value, if our leading number is negative, then we are going to factor out a negative. So if in this second half, this first one is negative, that then means whatever our GCF is, we want to make that negative. So instead of a positive 5, that's going to be a negative 5. A negative divided by a negative gives us a positive. Same thing here. A negative divided by a negative gives us a positive. And now we're in good shape. Our two binomials match. And so we have a 4v squared minus 5 and a 5v plus 6. Okay, one more we're going to look at, and that's what do we do if we have multiple variables happening. And the good news is that nothing really changes. We already know how to factor out a GCF if we have more than one variable involved. So we're just going to follow that rule here as well. So we're going to split this in half. Okay, and we're going to ask ourselves what goes into 3 that will also go into 9. Okay, they do not both have an A, so we can't pull out an A, but they do both have a B, so we can divide out a B. All right, so 3 divided by 3 is just 1. We could write that down, but we don't have to. There's an A left, and the B's cancel. 9 divided by 3 is 3, and again, those B's cancel. Then we're going to look on the right-hand side. What goes into 6, that will also go into 18. Well, that's a 6. They do not both have the A, so we can't pull out an A, but they do both have the C. Now, if we follow the rule that we just set up here above, right? If this leading one is negative, then whatever our GCF was, so we picked a 6C, but because that's negative, we're going to pick a negative 6C. And so when we divide that out, a negative divided by a negative is a positive. I'm only left with the A. A negative divided by a negative is a positive, and again, those C's cancel. So then we can put our GCFs together. Now this is, again, minus. This is a negative, so I'm putting a negative 6C, or a minus 6C, times A plus 3.